Hello everybody, it's Mr. Spinelli. Today we're going to talk about position, velocity, and acceleration, which later on we will be abbreviating PVA for position, velocity, and acceleration. So the first thing we got to talk about is position, and that determines an object's physical location. And typically in this class, single variable calculus, this will be where an object is located on a number line. Now our first example, we have x of t, which is giving me the particle's position, is given by this quadratic equation. And we want to talk about what x of 3 is and what it means. So we are going to substitute 3 in for the value t. So we'll do 4 times 3 squared, add 2 times 3. Subtract 1, and we end up with 41. Now my units would be some units of length, which my problem statement should provide for me. And what this means is that I'm 41 units to the right of 0. So my position would be somewhere over here to the right of 0. If I had a negative value, that would mean that I'm to the left. So down here you'll see I talk about the negative position, which is an object's position to the left of 0 on the number line, and positive position for us will be an object to the right of 0 on the number line. Now the next thing we need to talk about is displacement and distance traveled. Displacement is simply my final position minus my starting position. How far away am I from where I started? Whereas total distance traveled takes into account that I may have moved. So if, for example, I start at 0 and I move to the right to go to 5, and then I decide to go to the left all the way to -5, and then I go back to 0, so I've gone to 5, all the way to -5, and then back to 0, my displacement would be 0. Yet I traveled 5 to the right, 10 to the left, and then another 5 to get back to 0, my distance traveled would be a total of 20. So I can have a distance and have not been displaced at all. That means I started and finished at the same location. Now another topic we're going to see is velocity. This is the V of PVA. Now velocity is how fast an object is moving, which is speed, and it is the direction in which the object is moving. So velocity is both speed and direction. Speed is simply the absolute value of velocity. But we're going to be more concerned with velocity because it gives us both pieces of information, the speed and the direction. Now the first example we're going to look at is plugging in values for 0, 1, 2, and 3 for time t into 4t squared minus 16. So all I'm doing is simply plugging in 0 or substituting in 0 for t, and I get -16 when I evaluate at 0. When I evaluate at 1, I get -12. For 2, I get 0. And for 3, I get 20. Now the units of velocity are going to be length over time. Now this will depend on what we're working with, but it will always be units of length over time. This could be miles per hour, meters per second, kilometers per hour. It could be light years per picosecond. It could be anything that is length over time. Now the next question B asks, what are the speeds? The speeds are simply the absolute value. So I would get 16, 12, 0, and 20 respectively, and the units would still be length per time, but I have taken the absolute value. So I don't consider whether or not for V of 0 and V of 1 I'm moving to the left or backwards, and for V of 3 I'm moving forward in the positive direction, which is typically to the right for us, which is down here at the bottom. I discuss negative velocity and positive velocity. Negative, an object is moving backwards or in the negative direction, which for us is going to be to the left. Positive for us is typically going to be the right. That's a positive or forward direction. Now the next topic, PV, now we move to A, is acceleration. Acceleration is the rate at which the velocity is changing for an object. Now, acceleration does not give us a direct indication of whether an object is speeding up or slowing down. We will see more later how we determine that. Now, acceleration is going to be given by a of t. Now I'm going to compute that for time -1, 0, and 3 seconds. So when I plug in -1, I get -8. There's a negative. For 0, I get -5. And a of 3 will be equal to 4. So I've got a -8, a -5, and a +4. The units for acceleration are going to be length divided by time squared. Now, often units you would see are meters per second squared. Physics people are going to recognize 9.81. All my European folks in England are going to remember -32.2 feet per second squared, which is the US unit. So again, the units for acceleration are length per time squared. Now, negative acceleration means an object's velocities are decreasing. Positive acceleration means the velocity is increasing. And we'll make a connection to the calculus later on and what this means. So negative acceleration, velocity is decreasing. Positive acceleration, the velocity is increasing. So then how do we determine if things are speeding up or slowing down? An object is speeding up when the velocity and the acceleration are the same sign. So same sign is speeding up. Slowing down, the velocity and the acceleration are opposite signs. This is key. Now, how do all these connect to calculus? Well, position I usually denote as x of t. Velocity, denoted v of t, is the derivative of position, which we denote x prime of t. And acceleration, you can guess, a of t is equal to the derivative of the velocity, which turns out to be the second derivative of position. So here's our connection to calculus. Velocity you can think of as your derivative of position. Acceleration you think of as your second derivative, which gives us our concavity. So we're going to be making this connection on a few example problems after we discuss a topic that we reviewed recently. Now we're going to talk about average versus instantaneous velocity. In average velocity, you're going to compute the position of 2 points and find the slope between them. So that would be x of b over minus x of a over b minus a. So that would give us our average velocity. And b and a are typically going to be on either side of some point c that we want to approximate it for or average it. We might want to find the average velocity over a particular interval from a to b. Now for the instantaneous velocity, I'm simply going to compute v of c, which is equal to the derivative at the point c of my position function. Similarly, with average and instantaneous acceleration, my average acceleration is going to be my velocity at b minus my velocity at a divided by the difference between those 2 points, b minus a. So that gives me my average. And then my instantaneous I get by simply computing a of c for some point between that a and b interval, and that's equal to the derivative of velocity at c, which is the second derivative of position at c. So instantaneous, you got to be thinking derivative. Average, think slope of the secant line. Average, think slope. Instantaneous, think derivative. So let's get to the real meat and potatoes, our first real example. So the position of a particle is moving along an x-axis given by the following function, where x is measured in feet and t is measured time in minutes. So I want to determine when the particle is moving to the right or forward. So this is where I need to find v of t greater than 0, which means I need my derivative. Now my derivative of this particular polynomial is rather easy to compute using power rule. I get 3t squared minus 12t plus 9, which in factored form is 3 times t minus 3 times t minus 1. Now I'm going to want to compute a sign chart because I want to know where this function is positive. So my critical points are t equals 1 and t equals 3. So I'm looking at my velocity. If I plug numbers to the left of 1, I'm going to get positive. In between, I get negative, and to the right, I get positive. So when is this particle moving forward? From negative infinity to 1 and 3 to infinity, where I've indicated my sign chart to be positive. The next question asks where it's moving left. So I want v of t to be less than 0, which that's on the interval 1 to 3. So again, moving to the right is positive velocity, moving to the left or backwards is negative velocity. Now the fun question is, when is the particle furthest to the right, or when is it furthest to the left on a given interval? Now I've already done half the work. I know the only critical points on this interval are 1 and 3.5. So I need to, for the sake of both problems C and D, I need to compute my position at the endpoints, t equals negative 1 and t equals 3.5. So I'm going to evaluate these in the original function position, t cubed minus 6t squared plus 9t, the function that I started with. So I'm going to evaluate at negative 1, and I get negative 16, and those units are feet. I evaluate at 3.5, and I get 7/8 feet, or 0.875. And I'm going to evaluate at my two critical numbers, which were 1 and 3, from setting my derivative, or velocity, equal to 0. When I plug in 1, I get 4 feet, and when I plug in 3, I get 0 feet. So the question was, when? When I hear the word when, I need to be thinking time. When is it furthest to the right? Well, that's going to be when I have the largest positive value, which is when it equals 4 feet. So that would be at time t equals 1. I go back to my problem, and I recall that the time was in minutes. So I write time t equals 1 minute. Now, when is it furthest to the left? That's my largest negative value, negative 16. So that's when time t equals negative 1 minutes. Okay, so there's our first nice example. And we will now move on to another using the same exact equation with some slightly different questions. So let's proceed to the next one. We're going to talk a little bit more about velocity and acceleration. So same problem, x measured in feet, t in minutes, same polynomial. I want to know what the particle's velocity is at all of these times. Well, I already found my velocity. It was my derivative, which I will write again so we still have it. So it's x prime of t, which was 3t squared minus 12t plus 9. And I'm simply going to evaluate at all these points. So v of negative 1 you should find to be 24. And the units for velocity are feet per minute. Evaluate at 0, 9 feet per minute. Evaluate at 1. I get 0 feet per minute. Please check these with your calculator or by hand. I encourage you to try by hand. And check that I'm doing it right. Wouldn't hurt to get some comments. Make sure I'm doing things right. Keep me honest. So I get all these values. Notice that they are going from positive to negative and back up again. We've got a polynomial of third order, so it can move all around. We've got 2 zeros shown here, which are the maximum number of zeros I can get since this was the derivative of a third degree polynomial. My derivative is quadratic, so I got 2 zeros. Now the question asks, what is the particle's acceleration? Well, acceleration is simply the second derivative, which is the first derivative of velocity. So I'm going to take the derivative of my velocity equation to get 6t minus 12. And I'm going to compute it for each of these values. So at negative 1, it's negative 18. My units are feet per minute squared. So that time is being squared. Plug in for all my other points. Please check these again with the calculator or by hand. So if you ever forget the units for this, just remember that position was given in length. And when you took the derivative once with respect to time, you had feet per minute. Once you've taken the derivative a second time with respect to time, those units of time, minutes, need to be squared. So your derivative can give you a clue to what the units are. So again, we check all these numbers. Now, the key question the AP test is going to ask you, we're going to ask you, is when is the particle speeding up and when is it slowing down? So it's going to be key that I compare these results with one another. So I'm going to look first at when the particle is speeding up. So speeding up, I need the sign to be the same. I need the particle's velocity and acceleration to be the same sign. So I look, I've got a positive at -1 and then a negative acceleration at -1. Positive and negative velocities and accelerations respectively at 0. At time t equals 1 and 3, I have 0 velocities, so the particle is neither speeding up nor slowing down. And I finally get to my 1 point time t equals 4, where both the velocity and the acceleration are positive. I have no points where the velocity and acceleration are both negative, so t equals 4 is the only place where I am speeding up. Slowing down, I need them to be opposite signs. I've got one right away at -1, and I've got another one at 0. So you can see for each of these, the acceleration is negative and the velocity is positive. So these would be locations where I am slowing down. So that would be t equals -1, t equals 0. So again, these are opposite signs. Opposite signs. And for speeding up, I had same signs. Now, for example, we should discuss that at these points, when the velocity is 0, that the particle is neither speeding up or slowing down. If there is a change in sign, it is actually changing directions. We'll see more of that in just a bit. Now, the next type of problem we're going to look at involves a graph. Let's see if I can actually scroll down. So now we got a graph of a squirrel's velocity. Love squirrels, don't let them into your roof. They ruin things. Keep them off your house. Now the squirrel's velocity. So remember, velocity is the derivative of position. Got to keep this in mind when we answer the questions. Now, when is the squirrel moving forward? It's moving forward whenever this velocity is positive. So I just need to simply write where I'm above the x-axis, which is from 0 to 9, and on the interval 15 to 18. Again, that's where I'm above the x-axis. Now, when is the squirrel moving backwards? That's everywhere I'm below. So where is v of t? Less than 0. So that's going to be from 9 to 15. And where does the squirrel change directions? That is indicated by where I go from positive to negative. So I have to change sign. So v of t changes sign. And that happens at time t equals 9 and 15. Since we don't have units, we'll just keep it unitless, but this would be units of time. Now the next question asks what the acceleration is at a particular point. It wants to know the acceleration at time t equals 8. Now this is where I need to remember that acceleration is equal to the derivative of velocity. So I need to compute the slope here. Now this is a nice line, so I'm going to do my standard slope equation, y2 minus y1 over x2 minus x1, and I end up with -10. And these units would be length per time squared. But again, I'm simply counting the slope. Acceleration is the derivative of velocity, so it's the slope at a given point. Now the next question is usually the one that trips people up. It's where is the squirrel speeding up or slowing down? So remember, to speed up, I need to have the same sign for both velocity and acceleration. So this is same sign for velocity and acceleration. Well, what is acceleration in this picture? Acceleration is given by the slope. So acceleration, I need to look at the slope. So I'm going to focus on areas that are above the x-axis and increasing. So I'm going to actually just highlight all those areas. That way I don't have to think as much when I answer the questions at a particular time. So on these intervals that I'm highlighting in green, I am both above the x-axis, that is v of t is greater than 0, and I'm increasing, so I know a of t is greater than 0. Now I also need to consider the places where I'm below the x-axis and decreasing. So again, this is where I am negative for my velocity, and since the slope is negative, my acceleration is negative. So now I can more easily answer the questions of where the squirrel is speeding up. If I go through and make the same notations for where the squirrel is slowing down, I need to be above the x-axis and decreasing. So that would be this interval here. Or I need to be below the x-axis and increasing. So this would be where my sign is different, opposite signs. Now, just a further note that I might want to add, on these intervals here, these flat places where the slope of my velocity is 0, oops, accidentally erasing everything. Fancy book making things difficult. On these intervals where my velocity is flat, I have a constant velocity. So these would be locations where the acceleration is 0, so constant velocity. And the points that I will mark in black are where I am changing direction. So at these, I'm changing direction. I'm neither increasing nor decreasing my speed. So now I can go through and answer these questions. At time t equals 1, I'm right here on a green part, so I am speeding up. At time t equals 5, I'm in a constant interval, so I'm neither speeding up or slowing down. I'm maintaining constant speed. At time t equals 8, I'm here at a red spot, so that is where I am slowing down. At time t equals 9, velocity is 0, so I'm neither speeding up or slowing down. In this case, I have enough information to say that I'm changing directions. Now at time t equals 9.5, I'm here on another green spot, so I'm speeding up. My velocity is negative and my acceleration is negative, same sign. And at 14.5, I'm on a red spot, so I am slowing down. My acceleration is positive, but my velocity is negative, opposite signs. Now the last question is kind of a fun one. We're going to talk about speed. Remember, speed is the absolute value of velocity. And I can't get the bar in here. There we go. So, what is the squirrel's speed at time t equals 7? It's 20. I simply look at the y value given because this is the graph of velocity. I need to take the absolute value of 20. At time t equals 10, the y value is negative 10. I take the absolute value and I get 10. Again, my units for speed would be length per time. To graph this, if I wanted to graph speed given velocity, I'm going to do that here in blue. I'm going to do my best to sketch right over. And when I get to this part, I'm just going to flip it upside down. So everything in this region, which I will denote in red, where the velocity was negative, I simply flipped it over the x-axis because I took the absolute value. So everything in blue above the x-axis, the t-axis, pardon me, would be the squirrel's speed. It's the absolute value of velocity. So please come prepared tomorrow for some questions. Thanks for watching.